This is the review for finding a derivative the hard way. So let's start off with what is a derivative? A derivative is the general equation for the slope of a tangent line anywhere along a curve. That equation is crucial in order to understand any of what is going to come next. A derivative is the general equation for the slope, that's a big part of it, of a tangent line anywhere along a curve. So let's look at an example. Something like this. Say that's y equals x squared. So how did we find something for the slope of a line? Let's say we had a line like this. How did we find the slope of a line before? Well, a good way is the slope of formula. So the m stands for slope. So the slope equals y2 minus y1 over x2 minus x1. So that's a good equation for a line like something like this. If you had 2 points here and you wanted to find the slope of that line, you plug it into this slope formula. So you take whatever the y value is here, whatever the y value is here, minus the y value there over the x value of the first dot minus the x value of the second dot. Okay, that's something you probably learned in 8th grade. The slope formula shouldn't be too difficult at this point. The only problem is that if you look back at the definition for a derivative, it's not asking for a line that passes through 2 points. That's actually a secant line. So a line that passes through 2 points is a secant line. It's looking for a tangent line. And what is a tangent line? It's a line that passes through 1 point. Oh, let's see how close I get. Passes through 1 point on the curve. It's gonna be a little sloppy because it's very difficult to do it all here on this computer. So how can we find the equation for a tangent line? Well, let's look at it. If we wanted to find the slope for a point like, that was a terrible x-axis. We wanted to find the slope for a point here. How could we do that? We could take a point like this and do something like this and get the slope of that line. We can cut it down even further and get it. So you see the whole point here is that you can keep decreasing the amount of the second point. So if I had it like here, I could draw a line through. It's not going to be dead on. It's really hard to explain because obviously I can't draw it well. But you can keep cutting down the distance between the 2 points until the points are essentially on top of each other. And this is where limits come into play. Because remember that a limit is, you're almost there, but you're not exactly there. Because if we have the curve here, and we're looking for the slope at this point, let's say that's 1, 1, right? And we're looking for the slope of the line tangent to that point. And we plugged it into the formula here. We're going to get the same y value. So whatever, we're going to have 1 minus 1 over 1 minus 1. Because you're taking 2 points that are the same. And what do you know? You get 0 over 0, which is exactly what we got for some of the practice problems for the finding a limit. And again, that's called the indeterminate form. And when you see that, you have to do something. So what are you going to do here? You're going to use your knowledge of limits in order to find that. So the equation for a tangent line is as h, or the limit as h approaches 0, You know what? I didn't go over what h is. H would be whatever the distance is between 2 points. So if I had a distance, point there, that distance would be h. And we said that you can keep cutting down h in order to get to that. So again, a limit is, it's not going to exactly be 0, but it's going to be like 0.000001 in order to make it work. Because remember, if h is 0, then the points are on top of each other. And then you get the indeterminate form, 0 over 0. So the limit as h approaches 0 as the f of x plus h minus f of x over h. So how do I get that? If you actually look, it's quite similar to the equation down here. And why do I say that? F of x is just another way of writing y. So if you have 2 points, let's say y1 here would be your f of x. Y2 would be the f of x plus whatever that small amount is. So f of x plus h, f of x plus 0.00001, all over h. Okay. Let me just look at this here. And then for the bottom, the way that h is gotten is that x2 would be something like x plus h, and then x1 would be minus x. So then the x's cancel out. Just that's how you get that equation. If that's too confusing to follow, have this equation in memory. Limit as h approaches 0 for f of x plus h minus f of x over h. It is crucial, and I can't stress it enough, that you have this in the beginning, because without that, you're not finding a tangent line, you're finding a secant line. You will get points taken off if you don't have that. I'm going to erase this here, and we're going to plug in for that formula. So we have our equation y equals x squared, sorry. So we're going to solve this. So limit as h approaches 0 for, so what would f of x plus h be? So in order to find that, what are you going to do? You're going to plug in for y here in our equation, because we have y equals x squared. That can be rewritten as f of x equals x squared. Remember, because y equals f of x. So instead of just plugging in x squared though, because instead of x, you're going to have x plus h. So you're going to have x plus h squared minus, remember f of x is x squared. So it's going to be x plus h squared minus x squared over h. So then we can FOIL out the x plus h, and we get the limit as h approaches 0 for x squared plus 2xh plus h squared minus x squared over h. A good check at this point is that after you FOIL everything out, anything that doesn't have an h in it will cross out. So you see that the x squared and the minus x squared are going to cancel out, and every other term that's left here has an h in it. So I'm going to erase this. I'm going to erase this just to make a little bit of space. Let me just go over the steps so far. So you have your f of x plus h, right? Instead of just normal f of x, you're adding that little h to it. So whatever that value is going to carry down to here. So you're going to plug in for the equation y equals x squared, but you're going to have x plus h squared instead of just regular x squared minus f of x, because remember I said f of x is just regular x squared. So you're going to have x plus h squared minus x squared all over h. And make sure I'm keeping the limit here in front, because that'll come into play in just a minute. So now we're left with 2xh plus h. Sorry, you know what? I did that myself. Limit as h approaches 0. 2xh plus h squared over h. Notice that they all the terms in the top have a h in them. So I'm going to say limit as h approaches 0 for each step. You should make that your first priority. I'm going to pull out the h, 2x plus h all over h. You see that these two h's cancel out. And let's see if I can find some extra space. I'm going to continue up on the top right. So 2x plus h, and that's for the limit as h approaches 0. So now we can plug in 0 for h. And as soon as you cancel out the h's that you pulled out, you're no longer going to get that indeterminate form. So you're all good. So you get 2x plus 0 equals 2x. And that is going to be your answer. That's about the simplest way that I can go through it. It's essentially you're following whatever the rules were for the old slope equation for y2 minus y1 over x2 minus x1, but instead you're using it in terms of x and h. And h is going to be that small value in between the 2 points. Because remember, you're not technically taking 1 point, you're taking 2 points that are just ever so slightly away from each other. So f of x plus h is going to be the value of x plus 0.0001, whatever that small value is. And that's how you get to this x plus h squared value. Whatever that equation is that you're given, if it's like y equals x squared plus 3x, it's going to be the same thing, but instead of x, wherever the x is, you're going to plug in x plus h. That's the key. So if you get y equals x cubed plus 3x, I don't know, you're going to put in x plus h cubed plus 3 times x plus h. And then of course minus parentheses x cubed plus 3x. Getting a little sloppy here. I'm just running out of space. Make sure you have the parentheses here because that negative sign has to distribute. And then of course that's all over h. Just the point is that in the beginning part where it says f of x plus h, instead of just plugging in regular x here, you just plug in x plus h, okay? And then you just follow all the steps that I had here and went through for that one. And you can do that for any single equation. Okay, thank you.